Hello my dear friends, it's me Khan again, and today in this video we're gonna learn how to design the concrete beam. So in this video we're gonna learn how to design the concrete beam, and I will show you some shortcuts, some tricks in this video. So let's start. First of all, open your AxisVM, and or if you have open already, just click on the new and start a new file. Okay, select here the front view, and definitely we will design in the euro code. Okay, so ahead select the euro code, and then select here the units and format as well, the English euro, so English, and here you can set the name, and I'll just leave it like concrete beam slash concrete. Okay, so that's fine for me, and then click OK. So here you see the new file. So first of all, as you know that here you know, when you click him, bring your cursor here, you can see here the values. It's 000, so that's our global coordinate. But you can when you turn it off, you can work only in the global coordinate as well. But when you turn it on, so this lines, the yellow lines, that will be your global coordinate. This blue cursor, this blue point you can see here, I can shift it here. Okay, so this is your relative coordinate, or relative to the global coordinate, or you can also call it local coordinate. Okay, but for now it doesn't matter for us. Okay, so we're gonna design the concrete beam. So what you have to do, you just have to go to the elements. Okay, then click on the draw objects directly. Okay, then click here the horizontal beam, because we want to draw the horizontal beam with the supports, and then we will do the rest of things. And 1 minute, and then click on the horizontal beam. Okay, here are two options. One is the browse cross-section libraries, but we want to draw the editor. So cross-section editor, just go to click OK. Then this editor will be opened. Click here the tick, and here select the, now we will define the cross-section area for our beam. The cross-section area, I will show you here how what this cross-section we will set up here. Okay, 400 then by 720. Okay, and that's okay, and then place it here. Okay, and we will add something more as well, like we will add here a circular. Okay, and then we'll make it a polygon. I think that's a better idea. So let's come here, the diameter, they have given us a defined, 200 diameter, or that's fine, but we will try. Okay, 100 diameter. Okay, that's okay. I will click again. Okay, 200 diameter. Okay, no, that's again not fine. Let's go diameter, and angle should be 180. Why? Because we have to place it here, so like this, so that's why 180. Click OK, and now just place it here. Okay, that's fine. And now go to the polygon, click this point. Why I'm doing this, I will tell you why. Just wait a second. Okay, you can click here, you can see here different options, but I have already selected the line one. Okay, you can go with the tangent, R by center, R by 3 points, and different options are here. Okay, but I'm just going for the straight one. Okay, like this, and that's okay for me. This is not really that much good as I was expecting, but I think it's fine. Or maybe I will undo it. Okay, and I will make the circle again. It was 400, so I will make it 800 this time, so it's gonna be more better for me this time. Yeah, and that's okay, I think. I'll place it here. Yeah, okay, and now go to the polygon and define your shapes here. Okay, yeah, that's fine. Okay, so our cross section will be like this. Remember this picture, and then when we will design it, I will show you this cross section at the end. Okay, and then click OK. So this is the name of our cross section. Then click OK. When you click OK, the new window will be open. Here you have to define the material library. This is called material library. So here you have to define the material from which your beam is made. So definitely we are designing the euro code, so click here, then select here your concrete, steel, or anything you wanna, but we are designing the concrete. So we will design the concrete. Okay, so here we will select the C25 by 30. What does that mean? 25 is the shear, like the stress. You can see here like the values, the parameter is given for the concrete. So this is the stress in kilogram per cubic meter on the surface per surface, and 30 is also the stress, but that is if the concrete is in a cylindrical shape or a circular shape, but now it is in a cube shape, so that's why 25. Okay, then click OK. When you are click OK, then you have to select this option, beam polyline. Click on this, and then you have to view our local coordinate. Okay, click here. You can go by this as well, or you can write here the meter, how long beam do you want, or you can simply by your keyboard press X and then define your meter, how long beam you want. Okay, I will just type 10 and then click OK. So you see here, that's automatically, and then again press X and then 10 again. Okay, so like this you can go using the shortcuts. Otherwise you can we are in this Z and X coordinate. You can just press S, Z. I will show you how. Just press the Z key button from the keyboard and just type like 5 meter. I'll click OK. So now I have gotten this in the Z axis, but I don't want in the Z axis. Just press sorry sorry, like I pressed the Z, that's why, then I just undo and everything is just erased, but I will do it again for you, and that's fine. Yeah, okay, like you can use the shortcuts to draw it automatically and fast. So after doing this, just press the escape button, okay, 2 times. What next? Next thing we have, let's go to the geometry, and you see here this option that this is called geometry check summary. So just click on this. What will this do? This will just filter your beam for the errors. If there is any error in the geometry, so this will check it. Otherwise there will be, if there is no error, so it will show there is no error. You see nodes deleted, everything is shown here in the summary. Then click OK, so there is no error in geometry. Then what's next? Next is like I will show you just few shortcuts, like by I'm just zoom in. If you wanna just be like the concrete beam to be fitted to the window, just press Ctrl W. This will be fit according to your window automatically. But now it's too far, I will just press Ctrl W, so it will be fit according to the window. And the second shortcut for today is like Control M. When you press Control M, so now the cursor is changed into the hand. You can just simply move anywhere. Okay, or then you can press escape, it will be normal. Then Control W, it will be fit according to the window. And you can also zoom in by using the default plus button, okay, or default minus button. Using these two buttons, you can zoom in and zoom out as well. And now we will go to the here perspective mode. Okay, now it's too far, I will just press Control W. It will be fit according to the window size. And one more shortcut for today, just press Control W, and this will work in the perspective mode. And then press the or hold the wheel button of your mouse, then you can simply rotate here. Okay, then you can simply rotate. This is the shortcut for today. And one more thing, as I told you, just remember, I told you, like, remember the cross section picture. You see here, this is our beam. Okay, this is our beam, and you see here the cross section. It is we designed our cross section like this, and now you can see here at the ends of the beam, you can see this cross section. So our beam will be designed like this. Okay, otherwise you can just go by cube. I just did this to show you how it looks like, or if you to show you, to teach you more, that's why I did like this. So now Control W to be according to the okay, and then just go to your ZX mode, and that's okay, that's fine. Now the third thing is we have to define the supports reaction. Okay. static analysis. So when you click on this, it will filter your diagram, your beam from the errors. But this will only filter the basic errors. So when you click this, so it will filter the basic errors. So if there is an error, it will show you. But if there is no error, it will not show you. That it will everything will be 0 0, because it means there is no error. But if there is everything is 0, there is no error, it doesn't mean that your beam is completely perfect, because this just filters the basic errors. Maybe in reality you will get error which this analysis is not showing. So it doesn't rely only on this. You must design it correctly, perfectly, and then check it. If there is no error, then it is a positive sign. It's very good, but it doesn't mean that your beam is 100% correct, because it filters only for the basic errors. So that's all. So before starting this, one thing I forgot, that which you can do in the after setting the supports, then you can do, and also you can do at the end, or when you run this, then the system will do it automatically. But I will suggest you do it earlier when you put the supports, or I will do it now, it doesn't matter. What is that? We have to go to the elements. We have to set the freedom degree, nodal degrees of freedom. You can see here, okay, click this icon. So we have to set this degree for our nodals, and this is very important. You don't have to forget how you can select there, okay. First just go to the self load, okay, from the displacement, okay, then go to the elements and click this, okay, select on the star, select everything, okay, then you have to define it. We are in the zx coordinate, and this is simple beam, okay. So we will select the coordinates for our beam in which the our nodals can freely move, or we have to set that degree, okay, then click ok. And if it's a truss, then you have to go to set it in the truss, but it's a frame now, and we will go to the frame in xz plane, okay, then click ok. After this everything is set, okay, then just go to the static and run your analysis, static analysis, okay, then click on it. Mode is unchecked, start the analysis, yeah, just start it, okay. When you click on this, okay, you see analysis is completed and there is no error, okay, there is no error. Everything, like the number of equations here, equation memory, each and every parameter is shown here, and there is no error. If there is something error, then you have to correct it, and then run this analysis again. So now there is no error, click ok, and now you can see the it is completely perfect. Now you can go here for the diagram. You can see the diagram of your beam, and this is for the, I have selected here the z horizontal displacement, okay, so the perpendicular displacement, so it's showing me the diagram for the perpendicular. So you can change it to the horizontal displacement, then it can show you for the horizontal displacement. Here I will show you the units, other, like you can cross section and names and everything, you can turn it on. I will do in this case, okay. And the most important thing is here, like you can see this, no, not this, where it is, oh yeah, this is called result display parameters, okay, result parameters. When you click on this, okay, we will select here the service weight, okay, we will select the load case of the structure, and then you can see here the perpendicular displacement diagram. We want to see the diagram, and then click on undeform, okay. Why undeform? Because our structure is, it's a straight, so we want to see the diagram for the undeformed beam, okay. And then uncheck this, okay. Surfaces, we don't want the surface, we just want of the nodals and the lines, and this perfect, okay. And then click ok. Where is the diagram? Sorry. Yeah, this 20 millimeter, okay. So this is the deflection for our 1 minute. No, so bad. I think I have to the error was, like it has appeared now. The error was in the scale, okay. When you click on this, okay, this will be 1, okay. You have to change your scale, because you have to show it larger, because when you click on 1, so the it will appear here, but it will be very small. But when you click on this, okay, so change your scale and it will be large, okay. So this is the value for your undeformed structure, okay. So in this case you can see the values for your undeformed structure and everything. If you want to turn this on, it's not a problem anymore. And then you can go to the like you can go live load 1, and for live load 2 you can see the its values for the uniform. Okay, and then also you can go for the column number 1. Okay, this is for the column 1, and you can see the whole values. And then column 2 you can check, and then the column 3, you can see everything here. So this is very nice, I think. And then you can go here to the beam and internal forces. You can go to the rotation along the y-axis. So you can go to you can see now here the rotational values. Okay, along the x-axis. We have here only the hints. Okay, you can see here the maximum value across this. So it's very useful. You can go to the iso surface and you can see everything value here. So it depends on you which values is required. So you can see here from the diagram and everything. And one more thing I want to show you here is the maximum and the minimum values. When you click on this, okay, you have to simply say, oh sorry, you can just where is our no 1 minute self-pad, and then click the maximum. Yeah, it's here. So it was along the z-axis. Okay, I will click on this, and then you can see the maximum rotational value across the z-axis is this minus 268.58. Okay, like this you can get the maximum value and the minimum value. When you click okay, then it will show you the last one was the minimum, and this one is the maximum. The minus sign was with the minimum, and this is the plus, and this is maximum value. Simply for the live load you can go here, and okay, and then you can select the across the, like the m is the the moment. Okay, so across the y-axis, and this is the moment across the z-axis. So you can see the moment. Okay, this is the live load. It has the moment along the y-axis. So click on this, it will show you the minimum value first. It's in the negative. Then when you click again, it will show you the maximum value. So you like this, you can check for the maximum values, and you can go to the result parameters. You can see the find the values and the diagrams for your undeformed and deformed structure. So in the AxisVM you can do a lot of things. So it depends on you, sir, how you are using and how perfect so that's it's very interesting. You can get each and everything in the AxisVM. So this is how we can design our concrete beam in the AxisVM. Okay, so in the coming videos we will design the reinforced beam in the AxisVM, and we will learn more about this, and very interesting information, tips, and the shortcuts we will learn. So for now, bye bye, have a nice day. And if you have any comment, do write me. If you have any question, do write me in the comment, so I will definitely reply to you. And also subscribe my channel, and also hit the like button if you like this video, and if you think it's good. So it will appreciate me to make more videos for you. So for now, bye bye, have a nice day.